All right, you guys, you're going to want to open up this worksheet and you can just write it down on a piece of paper if you want, or print it if you want. And then when you're finished writing down the answers, make sure you label them, because you're going to take a Schoology assessment and that is going to be worth 20 points. You're going to get 3 tries at the assessment. So right here is where you just found the video and the worksheet, and then make sure you do the assessment. This is count as a school day, so this is technically due on Monday. Try to get it done today and done and over with. I'm going to do the first problem with you if you want, and I'm also show you what to do if you don't have a calculator with you. So I'm going to get rid of myself here. Okay, so this is question number 1. Let's read it together. The EPA reports the exhaust emissions of a car model is normally distributed. They tell you the mean and the standard deviation. So since it talks about normal, we know these are the Greek. The Greek letter means the population mean and standard deviation. So just label that right away on your paper. All right, this new car manufacturer claims their new process reduces the level of exhaust for this car. In SRS, that means a sample of 28 cars is taken, and the mean of those 20 cars is 1.21 grams. So everything in green is dealing with samples. So 28 cars, and their sample mean is 1.21. So let's state the hypothesis. So remember, your null hypothesis always goes back to the true mean. So your null hypothesis is just the true mean still 1.45. Since they claim it reduces the exhaust, you want to select the less than. And again, keep those both 1.45. Since it's a less than, when we do this on the normal curve, we're only going to shade to the left, which is 1 tail. Okay, feel free to type in these numbers into your calculator into a z-test, but if you don't have a calculator, it's okay. You can plug in these numbers by hand. So there is your x bar minus the true mean, standard deviation divided by square root of 28. And what I've done on Desmos is I went ahead, and you can type in numbers like that on Desmos. So our z value is negative 3.175. Negative 3.175. That's what would be the z value. So z equals negative 3.175. So the p-value, again, if you do this on your calculator tells you your p-value. If you don't have a calculator with you, we are going to have Desmos do the p-value for us. So if you just go to Desmos and you type in normal dist with parentheses, you guys can see this normal curve shows up. Hit the magnifying glass so you can see it better. And we want to shade everything to the left of negative 3.17. So I'm going to make negative 3.175. Hardly anything gets shaded. You can't even really see what's shaded. It's a really tiny number. This is your p-value, 0.0007. Very small p-value. So p equals 0.0007. Conclusion. Okay, remember, if p is small, reject the null. That's definitely small. So your null hypothesis, which you have written at the top of your worksheet, you're going to reject that. So here, put an X by your null hypothesis. So this is what we think is true. Okay, so you want to make sure in your conclusion you say reject the null. And then let's talk about what our alternative means. The true mean of the new cars is significantly less than 1.45 grams. So the true mean of the new cars emissions are significantly lower than 1.45 grams. Okay, so since we did an alpha level of 0.01, that's like 1%, the confidence level that goes with 1% would be 99%. And again, you can do that on your calculator if you have it. If you don't have a calculator, plug in the numbers that we know into this problem. The only thing that's kind of confusing, you might think this z is the same one as before. It's not. Use the 99% confidence z value. All right, so number 1's done for you. So you should get all those questions right on the quiz. And then you're going to want to do 2 and 3 on your own. And you're going to want to get your answers typed in into Schoology assessment.